Hello, advanced algebra students. Welcome back to another video lesson. Today we are going to be continuing with linear programming, looking at problem number 1 from your packet on page 15. Some students make necklaces and bracelets in their spare time and sell all that they can make. Every week they have 10,000 grams of metal and 20 hours to work available. Takes 50 grams of metal to make a necklace and 200 grams to make a bracelet. Each necklace takes 30 minutes to make and each bracelet takes 20. The profit on each necklace is $3.50 and the profit on each bracelet is $2.50. The students want to earn as much money as they possibly can. What number of necklaces and bracelets should they make each week to maximize their profit? So that last sentence or question really is the clue to this entire problem. What number of necklaces and bracelets should they make to maximize their profit? So let's say N is going to be our necklaces and B for bracelets. Okay, the number that we should make of each. The number of necklaces, and I'm just going to abbreviate for time's sake, the number of bracelets. From there, in order to help us create a table down here, we need to go back and figure out what are the constraints on this problem? Like, what are the limitations that we have to work with? And it's in the second sentence that they tell us every week we have 10,000 grams of metal and 20 hours of work available. So we have 10,000 grams of metal, 20 hours of work. So let's use that as our columns, metal and hours. And those two things are going to be used for our necklaces and our bracelets. And on the bottom as our constraints. So metal, we said 10,000. Hours worked, 20 for the entire week. So if we then use the rest of the information, we can fill in the rest of our chart. Metal, okay, takes 50 grams of metal for a necklace. So let's fill in the 50. And 200 grams for a bracelet. Whoops, bracelet down here. 200 grams for a bracelet. And then the hours. Now be careful. Here they're telling us that a necklace takes 30 minutes. And a bracelet takes 20 minutes, but we're talking about having hours available. So if they take 30 minutes for a necklace, that's a half hour. And if it's 20 minutes for a bracelet, that's 1/3 of an hour, 20 over 60. Okay, so there we've got our table to help us write the system of inequalities using the constraints. So let's use an inequality for metal. 50 times every necklace plus 200 times every single bracelet has to be compared to 10,000. All right, now we have 10,000 of grams to use of metal, so we could have it equal 10,000, or the amount we use has to be less than that. So less than or equal to 10,000. And then the hours. We have a half hour, 1/2 every necklace, plus we have 1/3 for every bracelet. We have 20 hours to work with, meaning that we could have less than or equal to 20 hours worked, right? Less than or equal to. And let's not forget that the number of necklaces we make should be greater than or equal to 0, and the number of bracelets that we make should also be greater than or equal to 0. Okay, so it's that information down here that we can truly use to then graph and find our feasible region. So let me slide that to my next page where I got more room to work. So there's our equations, our inequalities, and we're going to use x and y intercepts to graph. And so our x, let's say these are the n values for necklaces. Our y will be the b values for the bracelets. And let's just go ahead and use a different color here for this one. Say the top one is going to be blue. Okay. If we want to find the x-intercept, we have something comma 0, right? So 50n equals 10,000. 10,000 divided by 50 would give us 200. And then if we're going to find the y-intercept here, we have 0 in for the x. And we have 200b equals 10,000, or we get 50. So let's try and graph those. We're going to have to come up with some labels down here. X has got to go up to 200, so why don't we count by 25? 50, 75 makes that 100. 125, 150, 175, which makes this one right here 200. So that would be our x-intercept. And then if we count by, I don't know, let's just say tens. 10, 20, 30, 40, and 50 would be right here. And so if we graph those, we're going to get those 2 points. Now let's check 0, 0 for shading. 0 plus 0 is less than or equal to 10,000 is absolutely true. So we would shade everything underneath the blue line. I'm not going to go past the x-axis and the y-axis because, again, our last two constraints say we need everything that's positive. Right? So we would shade this area. Now let's use red for the next one. Okay, we'll use red here. Half n, right? So my y values are 0 if I'm getting an x-intercept. Half n is 20. Half of some number is 20, meaning that's a 40. Or the y-intercept here, 0 comma. A third of some number is 20. A third of what number is 20? That would be 60. So 60 and 40. So 25, 50, so, somewhere in here. Which means we have that line. And let's check 0, 0. 0 plus 0 is less than or equal to 20. That's absolutely true. So it would have to be everything underneath the red line as well. Which means we have this golden region from 50 down to 0, 0, 0, 0 over to here, up to the point of intersection and back. We have this gold region right in here. Or we have 4 different vertices. One vertex is 0, 0. Another vertex, if I go along the x-axis, is right here. Well, what was the x-intercept for our red? That would be 40, 0. Another intercept, if we go up the y-axis, is this blue y-intercept, or the point 0, 50. And then the last one is where those two lines intersect. Right in there, okay? The only way we really know how to find that intersection, though, is to use, in this case, probably elimination. So we're going to go to the next page where I've already got these equations written down for us so that we can use elimination to try and figure out where that intersection point may be. A little bit challenging because we've got fractions, and so a couple different ways that you could do this, I guess. I'm going to just try and multiply maybe, everything by 6 right away. Multiplying by 6 helps me eliminate my fractions. 3n plus 2b less than or equal to 120. Multiplying by that 6 helped me clear my fractions, a skill we learned earlier. And now I got to get some of these to line up or match. So the b's look like they're going to be a little bit easier to match. So I'm going to multiply this one, this bottom new equation here, by negative 100. All right, and I'm just going to write it down here after I do that so that it lines up. Negative 300n plus negative 200b, which is what we wanted, so that the b's will eliminate, less than or equal to, let's see, negative 12,000. Negative 12,000. And so now I'm going to add this top line. I should ignore that green dot, sorry. And this bottom line together. Let's add them together. 50 plus negative 300 is negative 250n My B values canceled, and we're going to equal 10,000 plus negative 12,000 is negative 2,000, which means if I divide everything by negative 250, oops, sorry, this should be 2,000, negative 250, we get N equals 8. The number of necklaces in that case would have been 8. We should use that to then figure out how many bracelets, right? How many bracelets would be at that point. I'm going to plug that back into this equation right here with a star next to it. 1/2 the necklaces, which is 8, plus 1/3 of the bracelets would equal 20. Or 4 plus 1/3 B equals 20. 1/3 B would equal 16. So 1/3 of some number has to equal 16. That number is 48. 848. So that's the point that we got for an intersection right up here. Right? 848. So that's our last point. Now, the question originally is which one of these is going to maximize our profit, right? Maximize our profit. And so the profit is going to equal, we got to go back to the original problem, $350 for a necklace that we make and $250 for a bracelet. So we got to use that in that maximizing profit equation. $350 for a necklace, or 350 times N, plus 250 times every bracelet. And then we're going to test each one of these points. Each one we will test to see what value we get. All right, so 0, 0. If I test the point 0, 0, that should be a pretty easy profit. We're going to have $0. Pretty easy to see that one. If I test the point 40, 0, 40 necklaces, no bracelets, 40 times $3.50 is $140. Not a bad profit. Let's try 0.50. 0 necklaces and 50 bracelets. Oh, sorry, I forgot my B in that profit equation. There should be a B right here. Sorry about that. So 0 necklaces, 50 bracelets, or 50 times $2.50 is $125. And last but not least, that vertex, 848. 8 necklaces and 48 bracelets would give them a profit of $148. And again, we're just plugging the first number in for N, the second number in for B, and evaluating this equation. You could then see, hopefully, and understand that if given the constraints of 10,000 grams of metal and 20,000 hours maximum, or 20 hours maximum to work, the best results, the maximum profit they could get would be $148 by selling and making 8 necklaces and 48 bracelets. If you have questions, please make sure that you reach out to your teacher. Let them know what you're stuck with. The best thing to do is always to ask whenever you need help. In the meantime, until we see you next time in our next video, stay safe.